Good morning students, this is Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. So in this video class, I am going to teach you about inductive proof. So subheadings of inductive proof is induction on integers, structural induction and mutual induction. Last classes I taught you about deductive proof as well as theory of computation introduction. Okay. So there is a proof, we have inductive and deductive. So inductive is a mathematical proof. So in inductive it is a special form of proof and it dealing with recursively defined object. Recursively defined object is nothing but for example, you see in a modern language we are using for loop. So whenever a loop is called, that means based on the I value, whether if the condition is true, it want to repeatedly or recursively execute the same statement. For that cases, this proof is useful. We have to check whether LHS is equal or whether the equation is valid. So in that cases, this inductive proof is useful. Many of the inductive proof deals with the integers, trees and expressions. Okay, I will teach you. In induction there are two parts, that is basis part and inductive part. We have to prove the theorem based on two parts, normally basis part and inductive part. So basis part we are assigning I equal to 0 or I equal to 1 or some value. Anyway, if you assign I equal to 0 or 1, we have to prove LHS equal to RHS. If both are equal, then the equation is true, otherwise the equation is not true. In inductive part, we are assigning S of n is an equation and we want to add S of n plus 1. That is, we can simply understood n plus 1 means next statement. So this is the theorem. This is very important 8-mark question. For all n greater than or equal to 0, summation I equal to 1 to n I square equal to n into n plus 1 to n plus 1 divided by 6. Prove this equation by induction, that means inductive method. So there is a proof I told you, there is a two parts, one is basis part as well as inductive part. Okay, so basis part I am assigning n equal to 0. You can ask, sir, only n equal to 0 only you want to assign? No, n equal to 1, n equal to 2, any value you can assign. But n equal to 0, whatever value you are assigning, you have to prove left side equal to right side. That means this summation I equal to 1 to n I square is equal to n into n plus 1 to n plus 1 divided by 6. Okay, so first I am taking LHS, that is summation I equal to 1 to n I square. So if you I consider n I value is, that means n value is 0. Okay, so summation I equal to 1 to 0 I square. If it is 0, then automatically the equation changes 0. So LHS I proved it is 0. And when I come to the RHS, n into n plus 1 to n plus 1 divided by 6, I will substitute 0 in the place of n because I am assigning n equal to 0. So I will get 0 into this equation. So 0 multiplied by any number, that is 0. So it is 0 divided by 6, 0. So I proved that LHS is 0, RHS is 0. So for basis this equation is true because I proved LHS equal to RHS. Come to the induction part, I told you it proves we have to add n value as n plus 1, that is next state we have to add. Okay, so I am taking LHS summation I equal to 1 to n I square. I am going to add n plus 1. Since it is I square, I am going to add n plus 1 the whole square. Since it is I cube, I will add n plus 1 the whole cube. It means I am adding n plus 1 based on inductive rule, inductive parts rule. Okay, so for summation I equal to 1 to n I square, I can apply this value. Which value? N into n plus 1 to n plus 1 divided by 6. Because equal to means this is equal to this. So in place of this, I can apply this equation. That's what I am applied here. Summation I equal to 1 to n I square. For this, I applied that n into n plus 1 to n plus 1 divided by 6. Plus this n plus 1 the whole square. Then ordinary multiplication. Before that, how I multiply is n into n square, n into 1 n, 2n plus 1. Okay, so now n square into 2n, 2n cube, n square into 1 n square, n into 2n 2n square, n into 1 n divided by 6. Now I am taking LCM. So if I take LCM, this is 6n square plus 12n plus 6. So it comes like this. Okay, and now I am going to add this exponential value 2n cube power 3 only 1, power 2 3n square plus 6n square, so 9n square it is here, and power n 12 plus 1, that is 13n and plus 6. So this is LHS for summation I equal to 1 to n I square in inductive part. Similarly, I have to prove RHS also. We know what is RHS. This is RHS. See the equation, n into n plus 1, 2n plus 1 divided by 6 is the RHS. So I am taking RHS, n into n plus 1, 2n plus 1 divided by 6. So what I am doing is n into n plus 1, 2n plus divided by 6. I am going to apply n plus 1 for n value, because I am assigning n equal to n plus 1. So n plus 1, n plus 1 plus 1, 2 into n plus 1 plus 1 divided by 6. So n plus 1, n plus 2 and 2n plus 3, because 2n, 2 into 1 2 plus 1 3. So 2n plus 3. Now I will multiply n into n, that is n square, n into 2n, then 1 into n and 1 into 2 2. So now I will get like this. Then I am going to multiply n square 2n, that is 2n cube, n square 3, that is 3n square, 2n into 2n, that is 4n square, 2n into 3, that is 6n, and n into 2n, that is 2n square, and n into 3, that is 3n, 2 into 4n, then 6. I will get like this. Then similarly I will add the exponential value. I will get 2n cube plus 9n square plus 13n plus 6 divided by 6. So see, LHS is also 2n cube plus 9n square plus 13n plus 6 divided by 6. RHS is also 2n cube plus 9n square plus 13n plus 6 divided by 6. So I proved NHS equal to RHS. So you cannot expect the same equation. We have lot of equations. So you want to know how to solve all the equations. If you refer your standard other book, you came to know many equations. So you practice from your home. So the thing is, we want to prove LHS equal to RHS in basis part as well as inductive part. Okay. Second one is structural induction. That first one is induction on integer. This is induction based on structure. Okay, so we studied trees in data structure. So based on the tree, it has one structure. So we are using structural induction, trees and expressions. Similarly, we have basis and induction part. A single node is a tree, that is basis part. I am taking a single node like this, single node, it is a tree. And induction part, if I have T1, T2, Tk, we have this much of nodes, then we can form a new tree. Begin with a new node, that is begin with a new node, and add a copies of T1, T2, Tk. This is T1 copy, T2 copy, 3 etc. Tk, and add edges from the node to the root node. This is the edges T1 to n, this is the edges, this is the edges. Likewise forming a structural induction. This is a structural induction. Okay, so it is deals with the trees and expression. Basis part, we are assigning only the single node, and induction part, we are copying the root node also. Okay, now mutual induction. What is mutual induction is, see, we have a separate statement like S1 of n, S2 of n, and Sk of n. This is the independent statement, and I will mutually inducted by using conjunction like a logical AND. S1 of n and S2 of n and S3 of n, etc., etc., and Sk of n. It means it is mutually, this is independent statement are mutually inducted by using conjunction. Okay, when there are really several independent statements to prove, it is generally less confusing to keep the statements separate. So we are mutually inducted, and it forms a common statement, that is mutual induction. Okay, so you have to remember, here we are using logical AND conjunction statement, and here we are using tree, and inductive on integers we are using mathematical induction. Okay, thank you. So next class I am going to teach you about finite automata and types of finite automata. Thank you.